Hi, welcome back, part 2 of day 3 related rates. So in this question right here, we have two trains are heading towards the same town, but are coming from different directions. So we're going to draw our town as a point here. Who knows, this might be Houston, so it might be H-Town or something like that. So we have two trains. Train A is 3 miles from the town and heading west. So it has to be going in that direction. So here's train A right there. And it is heading towards the town, right? This is our town right there. And this is train A. Train B is, and it's heading at 50 miles per hour. So I'm going to go ahead and write out my givens here right away. Train A, so the change in A, dA dt, would be 50. Now be careful, it's not going to be positive, it's going to be a negative. Remember we talked about, if the distance between the train and the town is decreasing, we can say this is negative because the distance is decreasing between the train and the town. So we say it's negative. Anytime we have a distance decreasing, we say the velocity is negative. And then we have train B. Now train B is heading north. Oh, here's train B. And it's heading north at a rate of 60 miles per hour. So I know that the rate of change in train B, dB dt, is also going to be negative because it's also heading towards the town, negative 60 miles per hour. And we also know that this distance here is 3 and that this distance here is 4. Now remember, these are variables, so these are changing, so I'll call this A for train A and this little b for train B. Now we also have a distance in between the two trains. Now, if this is A, B, and C, this distance is also going to change. This is very similar to the ladder problem, except with the difference here, now our hypotenuse is going to change. So this is going to be a variable too. We'll call that C. And we already know that even the length of C by looking at a 3, 4, 5 right triangle. So we know that this is just 5 right there. Okay, so now that we got all the picture, anytime you can draw a picture, it's really good. Listening at your givens, even better. Part A now says, how fast is the distance between the two trains changing at this moment? So they're asking us to find dC dt. Now there are a couple ways we can do this. I think we can use just Pythagorean theorem, but I want to use calculus. I want to use that related rate because that's what we've been talking about. So I am going to use my Pythagorean theorem, a squared plus b squared equals c squared. I think I could just do like negative 50 squared plus negative 60 squared. That's what I meant by earlier. But I want to use calculus because that's what the AP is looking for. When we take the derivative, we get 2a dA dt plus 2b dB dt. And that's going to equal 2c dC dt. Now we can help you out a little bit here. These 2's really don't matter much. They just all cancel out anyways if I divide everything by 2. And I plug everything in. So this becomes 3 dA dt, which is negative 50, plus b, which we know is 4, times the change in b, which is negative 60, and that's going to equal c, which is 5, times dC dt. And of course, this becomes negative 150 minus 240 equal to 5 dC dt. And if you solve it, oh no, I know what this is. This is what's that? Negative 390 divided by 5, which becomes negative 78. So we will say the distance between the trains. Now be very careful with this one. Take a look here. It's negative. The distance is decreasing. Is decreasing at a rate. At a rate of, again, that's negative, so where's the decreasing, so we make that positive, 78 miles per hour. And that would be our answer. Alright, now this is a fun question, part B. How is the area of the triangle formed between the two changing? So, in this case right here, now we are trying to find the change in the area. So I already used the letter A, so I don't want to use A again, so I'll use area itself, dt. So if I draw out my triangle again, anytime you can draw out a picture makes it easy for us. We already said that C here was 5 at the moment, A here was 3, and B was 4. And we're looking to find the change in area. Well, how do you find the change in the area of a triangle? Well, area itself is 1/2 the base times the height of our triangle. Look for that right angle. So it's 1/2 A times B. Now, we haven't done one like this before. This is a new one for us, so I want you all to pay attention. We can't replace A or B. Typically, like when we did, anytime we had like an equation, for example, think of the volume of a cone example we did earlier. You can check out another video I did on that earlier, volume of a cone. We can replace one of the two variables, but we can't do that here. We cannot use our triangle to write A in terms of B. So we have to use the product rule on this one. We kind of hit on that with this example over here when we talked about our trig one, right? Where if I did not pick if one of my variables was not constant, we had to use quotient rule. That's what has to happen if you have two variables that are different from each other, or that cannot be written as one another. So we're going to have to use product rule. Now, to make this easy, I'm going to make this 1/2 A times B. So when I take the derivative, we will get d of the area, dt would equal the first 1/2 A times the derivative of the second, db dt, plus the second b times the derivative of the first, 1/2 dA dt. And we just plug everything in. The change in area, dt would equal 1/2 A, which is 3, dB dt, which we know is -60, plus b, which is 4, times 1/2 dA dt, again, we got all this stuff up here, is -50. So remember, we got dB dt and dA dt from up here. And if we simplify all of this, okay, you're going to get -190 miles squared per hour. So we would say the area is decreasing at a rate, again, it's decreasing because it's negative, of 190 miles squared per hour. And that would be our answer right there. And the last one is, how fast is the angle formed by train A and the hypotenuse changing at that moment? So this is our change in angle. This is becoming really big on the AP. So we are trying to find the change in theta dt. So when I write this out, here we go. We know that this is A is 3, B is 4, C is 5. We're looking between train A and the hypotenuse, so we're looking for this angle right there. Now, the only difference between this one and the thing about the balloon problem is there are no constants. See, here we had a constant 4, but here there are no constants. This is kind of a tricky one for us. So when we write this one out, we have to make sure we can pick an angle that we know. So we're going to use any trig function that we want. And it doesn't matter which trig function you use. We know all of the values. So I just picked one of the easier ones I know, sine of theta. Sine of theta is the opposite B over the hypotenuse C. And again, there are two variables here. There are two variables, which means, can't spell variables. Therefore, we have to use our quotient rule this time. Well, this is a good question. So, taking the derivative, we would get cosine theta, d theta dt, equals the quotient rule, low, d high minus high, d low, all over the bottom squared. Now, because none of them are constant, that's what we have to use. Now, some of you are thinking, Mr. Werner, how do we get cosine of theta? Do we have to find the angle first? No, you don't. No, please don't ever do that. Please don't say cosine of theta is the adjacent 5. Whoop, oh no, that was a 3. It's a weird looking 3 right there. That should be a 3. 3 over 5. So I would do cos theta equals the inverse cosine of 3 over 5. And you would get some angle right there. I don't know what it is. And then you would say the cosine of that angle is what? Oh yeah, 3/5. I see people do this all the time. They actually write down what cosine of theta is, and then they find that angle, and then they use that angle to get the 3/5 again. Well, okay, and then they just stare at me like, yeah, that's what we're supposed to do. No, don't do that ever. We already have it, okay? You can do this, just a waste of time though. Cosine of theta we know is already 3/5. D theta dt is what we want, equals C, which we know is 5. dB dt, which we know already, again, dB dt is way up here, negative 60. Minus B, which is 4. dC dt, now be careful, dC dt, that's from part A. We found that in part A, that's negative 78. All over C squared, which is 4 squared. Remember, this was given, and this is part A. And if you type all of that in your calculator and you multiply through, you would get, so you get some weird thing here. Let's take a look here. We would get d theta dt would equal, and I'm just going to simplify a little bit here, 16 on the bottom. That's negative 300 plus, 4 times 78. I don't know what that is. Should give me a calculator, right? So I don't know. So I do 78 times 4. Don't be ashamed to ever do math. To carry the 3, 28, 312, right? Is that right? Oh, so 32, 28 plus, yep. So that's plus 312, and you're going to multiply that by 5/3. Don't ever simplify. This is going to be in radians. Be careful. And the time unit, we are in hours. And if you simplify that with the calculator, you should get 0.8 radians per hour. So we would say the angle is increasing because it's positive at a rate of 0.8 radians per hour. And that would be our answer right there. Okay, hope you guys enjoyed this video right here, and smash that like button. Smash that like button, okay? And I'll see you guys later. Bye-bye.